So this one's pretty good. I actually hadn't seen it on the breadboard yet. I was watching him talk about it. I like this kind of stuff. This stuff is my kind of stuff, and I knew it immediately as soon as I saw it. You use that on a farm tool, I want it. I gotta have it.
Hey, what happened, guys? Today we are going to talk about another classic circuit.
And you'll hear him say that a couple of times.
And this circuit is called the single-stage delay.
For me. Of course,
the reason
I
it's
wouldn't do
called
it
the
in front of the
single-stage
kids.
delay
I wouldn't
because
give it
it
up
only
like that.
uses the one transistor. We could add another PNP transistor in parallel with this.
As far as what is it doing
delay.
and the thing that it's doing, this could be its own little tiny PCB board.
That's something you guys want to
You
see.
could probably figure out a way to make it a
today
chip.
We're just going to talk
right?
about this single-stage
built-in
delay
resistor.
It's really simple. Like I said,
and another
it is
resistor.
A classic circuit you should know.
Probably because you'll need.
So people are always asking me, okay, so what can I use it for? Well, delay circuits are used for a lot of things.
Input,
now, one thing about this is, even though this is classically called a delay circuit, I would call this more of a timing circuit.
Power is going to come through the negative and go to the positive,
turn
classically.
On when you press the button.
Now,
so think of it that way. Of course, you can move the components around and have it so that the LED turns off, but I'll leave that to you.
Yeah, no, where's the diode, really?
So what do we use it for? Well, you
would think, oh, it doesn't have a circle on it. It's like diodes don't need to do that, depending on who does it,
if you have
based
a
on the
single-stage
delay.
This switches on,
for before you get into the timing
then we can
on
switch
the 555 or an 8-bit, to do the Arduino, to do things for you, this thing is like one of the special logic gates in its entirety.
It's fun to know how these things work made out of discrete components.
And so, okay, now that I got you,
well, let's take a look at this circuit and examine it and figure out how it works. Now, my camera...
He kind of did the middle phase, 3 degrees, right?
It already has
His apprentice, that's good. I'm going to usually pick up on the farm notes.
4.2 volts DC. It really doesn't matter.
Classical stuff, real basic tool version of it that comes up that'll be something that you could train in any class, and you're probably going to hit a timing that leads into the double
transistor. In this case, we're using the 2N2222A, but it can be any NPN transistor because the gain doesn't matter. We're basically using it as a switch.
They
turn it on,
and Big Mario into Little Mario, and then
now right here is our capacitor in the circuit.
Or whistles.
And between the capacitor and this resistor, we are going to control the timing of this circuit.
The tool's laying all around.
But don't think of this as an RC circuit. It's really not. The charge-discharge rate
did you see
of the
his
capacitor
is
what is mainly controlling the timing. Now, this resistor, in the case we're using in our circuit, is 1 meg. It is going to limit the current on the transistor, which is going to only open up the gate here. Not the gate. Well, I call it the gate. It's only going to open up this channel
Let me jump
from collector to emitter so much. We can open up a little bit, we can open it up a lot. If you open it up a lot more current's going to flow and it's going to discharge the capacitor faster.
I'm not going to
so
ship
by
off
only opening it up
Amazon
a little bit,
on a breadboard.
we can add time to this. And this circuit
that
is going to work for
like temperature. Feels like it increases the temperature. And
now, if you want to change it, you can simply
change.
And
then when another one trips this, it does it individually
over. So how's it work? Well, you press
instead
the
of programming the milliseconds over by the algorithm,
flows down from our source
0.01, 10 to the negative 6, and 10 to the third, multiplying that mess together about numbers.
From our source
Bernoulli, not just on this
lighting
input,
our LED,
but 1K resistor,
that channel
1K resistor, we got an LED.
Now, at the same time,
if the resistor smooths it out before it gets here based on those parallel waves,
at the same time that button is pressed,
that wants to just skip off over here in the rectifier. Is that what it is? You got the
let go of the button.
The way it does
the charge from that capacitor is going to flow.
These are all NP materials,
so we're always getting a
they want
positive
F1 plus F2, but both ways at the same time, and that's why you get that. Why this one is a good one.
Coming down from the source or up from the capacitor, it doesn't matter. And until that capacitor completely discharges,
I guess
the transistor will
you could say that is a relay. That is the coil,
Simple
right?
enough for you.
And inside here's the little way that it does. And there are
take a
the
look
two.
At the one I put together on the breadboard.
Then you get into
so there it is.
why
Looks pretty
there's
much like what you see.
A double forward backwards relay.
Let's zoom in here a little bit.
Yep, that's what would happen.
There is our 2N2222, and it is set up emitter base collector.
That's tight.
There's our emitter going directly to ground the base, that middle pin. is going
And
through that
buttons are
1
two
meg
different
resistor
sizes.
to
We
one
have two
side of the
different.
switch. The other
We
side
have
of
two
the
problems
switch
in the
is going
manufacturing,
to VCC.
and they have to do the same
Coming
thing.
from VCC here
It's a weird
is our 1K
number
resistor going
about
to the anode
kids losing it.
of that LED.
If you can pull that out, you pull out some of the noise.
Goes to the collector, which when the base opens the channel will flow through the collector, out the emitter,
this is going for the
and
internet.
to ground. That's it, man. That's all there is to it.
Cloud ground. There's the breadboard
So
factory.
let's make it work.
Oh, cute little breadboard too.
Hook up the power.
And then you'd get the PCB printer running, right? You would start drilling it out. You'd be like, okay, how do I want it tight where the wires don't do anything, and so it's the tightest, smallest geometric space possible.
8. Watch it not go out. Watch it prove.
Then you show me the computer, and it's not so much anything. It's like, okay, get this file, get into there. Remember, open the coffin, get in there, spiral staircase, scarecrows. Oh yeah.
That's definitely dimming. It is.